So picking up where we left off, we were just talking about going back and forth between rational form and radical form, okay? And now we're going to get into simplifying. Now, if you look at this problem, I see to the 4th root and I see to the 8th root. So you might be thinking that you can't do this, but you actually can because they're both x's. So you have the same base. So anytime that you have the same base, you can convert it to rational form. Follow your exponent rules, or those shortcuts that we talked about. And then take it back to radical form, okay? And a prime example of that was way back up here when you had these ones that were to the same base, so we just added the exponents, okay? So down here, if you have the same base, convert it to rational form, and then just use your exponent rules, and then go back to radical form, okay? So if I take a look at this problem right here, my numerator would be x to the 3/4, and my denominator would be x to the 2/8. Now, 2/8 is really just 1/4. And whenever were dividing, you would subtract your exponents. So really, this is just x to the 3/4 minus 1/4, because it's the same base. So 3/4 minus 1/4 is just 2/4, which is just a half. So what is x to the half power? That's just the square root of x. So anytime that you have the same base, just convert it to rational form and then go from there, okay? So taking a look at this one over here, I'm going to go ahead and convert this to rational form. So this would be 3 to the 1/2 times 3 to the 1/4, okay? Same base, so I can add my exponents. So a half plus a fourth, so think of a half as 2/4, so a half plus a fourth would be 3/4. So that's 3 to the 3/4. So in radical form, that would just be the 4th root of 3 cubed. And you can leave it just like that, that's fine, okay? You could also say the 4th root of 3 times 3 times 3 is 27. So you could do that as well. It's just up to you if you want to do that or not, okay? Now, over here, I just have 16 to the negative 2.5. So it's in rational form already, okay? I don't have multiple things, so I'm not going to follow this rule up here. Same base, rational form. It's already in rational form, okay? So negative 2.5 is negative 5/2. So really this is just 16 to the negative 5/2, which remember would be 1 over 16 to the positive 5/2. That flips over to the denominator. And then the half is just a square root. So that's going to be 1 over the square root of 16 to the 5th power. Now, just ask yourself, what's the square root of 16? You could do 16 to the 5th power and then try to break this all down. But it doesn't necessarily matter whether you do the numerator or the denominator part first, whether you do the 5 or the 2 first. So if you remember that the square root of 16 is 4, then this is just going to be 1 over 4 to the 5th power. And you don't have to find out what 4 to the 5th power is. If you don't have a calculator especially, feel free to just leave it just like that. Okay? Taking a look at this one, I have negative 32 to the 4/5. Now, that's not a negative exponent, so that's not going to flip or anything. That would just be the 5th root of negative 32 to the 4th power. Now, if you don't know what negative 32 to the 4th power is, that's fine. I don't expect you to. But what is the 5th root of negative 32? Find out what that is, and then that will be to the 4th power. So the 5th root of negative 32, 32 is 16 and 2, and that 16 breaks down into a bunch of 2's. So if you didn't catch it, the 5th root of negative 32 is going to be negative 2. And then to the 4th power, so you could just say negative 2 to the 4th power and leave your answer like that. Or negative 2 to the 4th power is just negative 2 times negative 2 times negative. That's just positive 16. So it doesn't necessarily matter which way you write it, okay? So if you have the same base, go to rational form, use your exponent rules, and then just go back to radical form. If it's already in rational form with an exponent like these ones are, then convert it to a radical and then simplify from there. Okay? So taking a look at this one, I have 32 to the negative 3/5. So that's going to flip it over to the denominator. So this would be 1 over 32 to the positive 3/5, which would be the fifth root. We just did the fifth root of 32. So think back. We literally just did 1 over the fifth root of 32 and then cubed. So the fifth root of 32 is positive, just 2. So this would just be 1 over 2 cubed. And 2, I kind of expect y'all know, you just say 1 over 8. Little ones like that, you should know. Like you probably know 2 cubed, 3 cubed, 4 cubed. You should know those. So it's fine to just write those ones out. Okay. Over here, you have a mix. I have one in radical form and I have one in rational form. Okay. So I'm going to convert everything to rational form and I'm going to go from there. Now, all of this is being raised to the 2/3, but only this part has a square root to it. Okay. So I'm going to break this down. I have negative 8x to the 2/3 times xy was to the 1/2 to the 2/3. And whenever you have an exponent and an exponent, so a power to a power, remember that you multiply. So 1/2 times 2/3, the 2's will cancel. That's just going to be to the 1/3. Okay. So what you have is you have negative 8x to the 2/3 and you have xy to the 1/3. So what you have is the cubic root of negative 8x squared. Okay. And then you have the cubic root of xy. Now, you can expand and combine all of this if you want to. But where I would be careful is that you have negative 8x squared. So what that's going to become is that's going to become 64x squared. That's not negative 8x squared. That's 64x squared. So that would be 64x squared times xy. So this would be the cubic root of 64x cubed y. And if you know your cube roots, or if you caught that the cubic root of negative 8 is 2 and 2 squared, that would break down into 4, 4, 4. The cubic root of x cubed would be x. So this would become 4x, the cubic root of y. So if you have a combination of things, like I took it to rational form and then I went back to radical form. Sometimes you have to go back and forth, but remember that we always end in simplified radical form, okay? Now, I would pause here and see if you can try these next ones on your own and then come back to the video, but I'm going to go ahead and keep on going. Okay, I have 16y to the negative 8 to the negative 3/4. Okay, all of this is going to the negative 3/4 power. So I'm going to break this down with this part first, and then I'm going to do the variable, kind of like what I did in the last one. So that would be 1 over 16 to the 3/4. And then that would be y to the negative 8 to the negative 3/4. And a power to a power, remember that you multiply. So negative 8 times negative 3/4 would be positive. 8 divided by 4 is 2 times negative 3, so we're positive 6. I think I said negative, but it should be positive 6. Okay. So what you really have here is y to the 6th power. The 2 negatives canceled out, so that should be in your numerator. Over the 16 went to the negative exponent. So that would be the 4th root of 16 cubed. Okay, like what I had over here, but this part should be positive. It should be in the numerator. Okay, now if I look at this, you can't have a radical in the denominator, but if you think about the 4th root of 16, the 4th root of 16, 16's 4 and 4, and that breaks down to 2 and 2 and 2 and 2. So the 4th root of 16 is 2, and then you add 2 cubed. So what's 2 cubed? 8. So you don't even have to rationalize your denominator. This is just y to the 6th over 8. And that's it. Okay. Over here, I'm going to do what I did with the last one, which is where you can kind of break it up piece by piece. So I have 8 to the negative 1/3. So that would be 1 over 8 to the 1/3. And then I have x to the 15th to negative 1/3. So that would be 1 over 15 times negative 1/3 would be x to the negative 5. So that's going to go in the denominator. So that would be x to the 5th in the denominator, okay? And then from there, what's your cubic root of 8? 2. So this would just become 1 over 2x to the 5th. Now, some of you are just really in radical mode, and so you're going to take this, and what you're going to do is the fact that all of this is to the negative 1/3. So you're going to say, well, that's just 1 over, because it was negative, the cubic root of 8x to the 15th. And you're going to break it down that way, and you would still get the exact same answer, okay? So let's take a look at a couple that are a little bit more complicated. So right here, have everything to the 3rd power, which means that everything is going to be to the cubic root. So no negatives, don't have to worry about that. So my numerator is going to be the cubic root of 27x to the 6, which simplifies, and I'll deal with that in a little bit. My denominator is going to be the cubic root of 64y to the 4th. Okay. Now, if you know your perfect cubes, which you should, the cubic root of 27 is just 3. So that's going to be 3x to the 2nd power. Okay, 6 times the 3rd is just 2. So 2 groups of 3. Okay, over the cubic root of 64 is 4. And then I have one group of 3 in there. So 4 to the 1/3 would be 4/3. So I've got one group, so 1y. And then I have a remainder of y, so that would be the cubic root of y. Okay, remember what I told you about my Algebra 2 teacher? Like, when in doubt, expand it out. So if you need to look at this and be like, that's 8 times 8, that breaks down into this. Y to the 4th is y and y and y and y. Like, expand it out if you need to expand it out. Okay, once you've done all that, really the only problem is this part. That's the only part that needs to be rationalized. So remember that it's a cubic root. So I want 3 of a kind, okay? So I have 1 right now, so I'm going to multiply by the cubic root of y squared in the denominator and in the numerator because I want 3 of a kind. Now, the cubic root of y times the cubic root of y squared, that would be the cubic root of y cubed. There's 3 of a kind, that would be y, but I also add another y out front. So my denominator is not 4y, it's 4y, which would be 4y squared. And then in your numerator, 3x squared cubic root y squared. And then that's it. Okay. Now, over here, I'm seeing the same base. I'm seeing a lot of things happening. I'm seeing the same base here, and then I'm seeing the same base there. Remember, if there's no exponent on it, that has an exponent of 1. Okay. I'm going to start with what I have inside, and then I'm going to deal with this squared. So using my exponent rules, remember that anytime you're dividing, you're going to subtract your exponents. So I have x to the negative 1/3 minus 2/3. So negative 1/3 minus 2/3 is negative 3/3, which is negative 1, which means that my x is going to go in the denominator. Like I said, we'll deal with the squared part in a little bit. Okay. Over here, I have y to the 1st power minus, so I have 1 minus what I have in the denominator, which is negative 1/2. Remember that whenever you divide, you subtract. So I've got 1 minus negative 1/2, which is really 1 plus 1/2, which is 3/2. And that's positive. So this y in the denominator was moving up here, and this x was really moving down there. So I end up with y to the 3/2 in the numerator, okay? Now, remember the thing with rational form is that you can apply all of those little exponent rules and shortcuts and then try to simplify it, okay? Because once you do that, remember that a power to a power we multiply. What's 3/2 times 2? The 2's just cancel, so that's y cubed in your numerator. And then in your denominator, you're going to get x squared because that's a 1. 1 times 2 is 2. That's it. So I don't even have to go to radical form. Everything kind of worked out really, really nice and neat, okay? So when in doubt with a problem, expand it out or switch it to rational form. Use your little shortcut rules and then convert it to radical form, okay? And then for our last one, we're going to look at a word problem. So Kepler's third law of orbital motion shows how you can approximate the period P in Earth years that it takes a planet to make an orbit around the sun, okay? Or an orbit of the sun. So here's our function for that. Where D is the distance from the planet to the sun. So D is the distance from the planet to the sun in astronomical units, or AUs, okay? And just so you know that 1 AU is 93 million miles, so it's very far, okay? How many Earth years does it take for Mars to orbit around the sun? So P equals D to the 3/2, which is just the square root of D cubed. And the distance, if I look over here, it tells you (1.52 AU). So what's the square root of 1.52 was our distance cubed, okay? Now, we're going to round this out. We're going to do this one in the calculator. This isn't a problem where I would like expect you to know how to do this, you know, like 1.52 cubed, blah, blah, blah. Like you have a decimal. This is a problem where you would have a calculator. Okay. What I want to show you is that you could type this 2 ways into the calculator, okay? So I hate the new split screen, you guys. I feel like an old person trying to use it and trying to figure it out. Are we there? Did we get it? Okay, got it. Okay. You can type this in as a square root of 1.52 cubed. Like that. And I get 1.87. Okay? How you can also type this in is I could do parentheses 1.52 to the power of 3 divided by 2. Like that. And notice that you get the same thing, 1.87 for both. So back to our word problem. See, now I'm back to having trouble with this. Just want to make it full screen again. There we go. Okay. So how many Earth years does it take for Mars to orbit the sun? Well, we just did it in the calculator. So 1.87. So our answer would be it takes Mars 1.87. Remember, P was already in Earth years, okay? So it takes Mars 1.87 Earth years to orbit the sun. And that's it, okay? If you're having trouble with this, I'll be available for tutorials before your quiz, okay? Or go back and re-watch this video because your quiz is going to be over radicals, rationals, simplifying, all of that. So you're going to want to know how to do these problems where you have to kind of go back and forth on them. Anyways, good luck with your practice. I'll see you next time.